All right, now we're going to look at the problem set for 2012. Yeah, we're going to skip 2011 for now. You can do that one on your own. 2012 has some good stuff for us to look at, starting with the A problem. First thing we'll have to do with these statements is translate them into conditional form. So don't forget, we're always going to look for if to start our conditional. So if you look at the first statement, starting with the if, it says if Bella does not believe him. If she does not believe him, then he will not call her. The next statement says either Edward is in love or his heart is playing tricks. Remember, or means one or both of those statements must be true. The next statement, the third one, says Edward will call Bella if and only if he is in love. Remember how the biconditional works. If he calls her, he is in love. If he is in love, then he calls her. That's what if and only if means. The statements imply each other. The last statement says that his heart is not playing tricks on him. Just like before, we'll have to form these statements into a chain leading to each other to reach our conclusion. We know we have to start off with the only statement that is not a conditional. Edward's heart does not play tricks. What other statement do we have about tricks? Well, we know that one or both of these is true. Because we know that this is false, we know that this must be true. That's how we can use the or statement to find one more step of our chain. Next, we'll use our biconditional statement backwards. If he is in love, then he will call her. So far, we've used 3 of our 4 statements. How do you think we'll use our last one? We know that he will call her. That means we can use the contrapositive of the first statement, which always must be true. The contrapositive would mean, if he calls her, then she believed him. To put that in sentence form, our answer would read like this. Just like before, we put our statements into a chain, one leading to the other until we got from where we started to where we finished. Remember, we could use our or statement, meaning that one or the other side had to be true to decide which side had to be true. We're also able to use the contrapositive of statement, which must be true if the statement is true, to create a better form for our chain. Using all 4 statements, we are able to come up with a conclusion. The B problem for 2012 is also pretty easy. We'll just have to be careful not to make any mistakes. For statement A, the first thing we're going to do is we're going to take the inverse. To take the inverse, you take the opposite of both sides. Then we'll take the converse of that. To take the converse, you switch the 2 sides. For statement B, we'll start off by taking the contrapositive, which means you will take the opposite of both sides and you will switch them. Then we'll take the inverse of that, which means you will take the opposite of both sides. Statement C, we'll start by taking the inverse. Once again, inverse means take the opposite of both sides. To take the contrapositive of that, we'll take the opposite and switch the sides. For statement D, the first thing we'll do is we'll take the converse. To take the converse, you switch the sides. The second step of that, we'll take the inverse, taking the opposite of both sides. For E, the first thing we'll do is take the inverse, the opposite of both sides. The last thing we'll do is we'll take the contrapositive, which is taking the opposite and switching the sides. Now, the question asks us to find which ones are logically equivalent, not merely the same. We know that A and E are exactly the same, so they must be logically equivalent. We also know that a statement and its contrapositive are also always logically equivalent. The contrapositive of our two matching statements here would be if P, then not Q. That's statement D. A, D, and E are all different ways of saying the same logically equivalent statement. Therefore, our answers are A, D, and E. Don't forget how to take the inverse, converse, contrapositive of every statement. And now for the C problem for 2012. I'm actually going to attempt to draw it this time so you can see how I do it. I'm going to make 3 lines going this way. Then I'm going to make 3 lines going the other way across them. Now, finally, I'm going to draw my 3 horizontal lines. Pretty good, right? If I can do it, you can do it too. Let's go ahead and label our 3 categories. Remember, we're able to do this because they're mutually exclusive. No 2 teachers have the same first name, same last name, or the same subject. Because they're all mutually exclusive, when we find one, we can cancel out the others. The first names are Alice, Bob, and Carl. The subjects they teach are geometry, health, and Italian. And their last names are Dobson, Ellis, and Foster. Now we'll use each statement to fill in the grid. The first statement said that the geometry teacher's first and last names are not Alice or Ellis. So the geometry teacher's first name is not Alice, and their last name is not Ellis. So we've got 2 X's already. The second statement says that Dobson's first name is not Carl, and neither Dobson nor Carl teaches health. So if we look at health, it's not taught by Carl, and it is not taught by Dobson. The third statement says simply that the geometry teacher's last name is not Foster. That already gives us enough information to put an O on the grid. We'll continue on to the fourth statement. It says, neither Bob nor Foster teaches Italian. We look at Italian, it's not taught by Bob, it's not taught by Foster. This gives us enough information to fill in the top grid. This time it's going to be tricky to fill in the other grids. Why don't we take a look at the geometry teacher, for example, whose last name is Dobson. Because we can't make this triangle, it's blocked by an X, we can block this piece out as well. We know that geometry teacher's first name can't be Carl because this triangle already has an X in it. Because this part of the triangle is blocked out, we'll put an X here as well. Again, an O and an X makes an X. An O and an O makes an O. We now have enough information to fill out the grid on the bottom left. Now, all we have to do is find the two O's to put the third one. We have one triangle right here, the two O's, so we'll put the O here. So again, we have two O's, the third O goes here, which means that the last O must go here. Therefore, what are our answers? Well, the geometry teacher must be first name Bob, last name Dobson. The health teacher must be first name Alice, last name Foster. The Italian teacher must be first name Carl, last name Ellis. Congratulations, now we're done with logic. You can use the other practice sheets to practice on your own.